Today we're going to start talking about logarithmic functions. So when we were talking about exponential functions in the previous several sections, we mentioned that there's eventually going to be a way to solve equations with variables in the exponents. In order to do that, though, we need to learn what the opposite of an exponent of x is, and every mathematical operation has an opposite. So multiplication and division, addition, subtraction, in this case, exponentials and logarithms. Every mathematical operation has an opposite, and the opposite of taking the expression to the x power is taking the logarithm of the expression. Alright, we might not know what a logarithm looks like just yet, so let's set it up kind of like this. So a logarithm has a base of b of a positive number that satisfies the following definition. As long as b is positive and not equal to 0, then log base b of x is equal to y if and only if b to the y equals x. So how the heck do I read that funny log thing? Well, kind of already spoiled that for you. You read that as log base b of x. In other words, the logarithm equals the exponent to which you must raise the base to get x. There's a couple quick rules that you need to know. There's always log rules and all these other kind of deals, which we'll talk about more later. Because an exponential and a logarithm are opposites, if you apply both rules, they will cancel each other out. So just like 1/2 times 2 would just be 1 because they cancel each other out. The multiplication undoes that division. So for instance, if I've got b to the log base b of a, it should just be equal to a, because as long as those bases match, you're golden. Same thing with log base b of b to the a is just going to be a. And that's one that we forget a lot, sometimes myself included. I'm not going to lie, I will sit there and look at one of those problems for about 30 seconds and be like, oh yeah, that's a thing. It's just one of those last thing to my mind type of deals, but still comes to me within 30 seconds. As long as you apply both rules, assuming we're going to be using the same base, they will cancel each other out. These rules will be really important later, but not so much for right now. Today we're just going to be writing the exponential equations in logarithmic form. We're going to be evaluating simple logarithms just to kind of get used to this. Why? Both of these will be important when we're trying to solve equations that involve either exponentials or logarithms. So how do I rewrite the exponential expression using logarithms? Well, we just use that definition. If b to the y equals x, then log base b of x is equal to y. So again, you always want to equal to the exponent, and you always want that base to match. It's probably the easiest way to think about that. One other definition, it's pretty common that we'll be actually using a lot. The common log is the logarithm with base 10. So when our base is 10, we don't need to write the base. This is just our log button on our calculator. And then one last thing, there's something called the natural log. No, I'm not talking about the ones outside. We talked about the number e in the last section, and if this number is used as the base of a logarithm, and it will get used in the base of a logarithm, then we're going to use what's called the natural log. This is usually your LN button on your calculator. And that's about all we need to know to start doing problems. So I will see you guys in the next video, because that was a lot of reading.